So we're just going to barely touch systems of equations, and then you guys are going to come back to it a lot next semester at some point, okay? Come back and review lines, that way you get to see them many, many times. In Algebra 2, you don't keep reviewing stuff over and over again. In any class after that, you don't keep reviewing stuff. They expect you to know it, and we move on, always. So this class, though, we're going to review things several times. So systems of equations are just taking one of the things you already know. The only kind of equations we know so far are lines, mx plus b, right? Which I think these are, right? You can see mx plus b's in there? Yeah, just lots of mx plus b. The only other kind of equation we know so far is basic exponentials, y equals ab to the x power. So we're not even going to throw that in today. We're just going to stick with lines and thinking about more than one of them at the same time. That's the idea of a system. So a system is uniting two lines at the same time and asking yourself, what number, or numbers, in fact it's going to be numbers because they're going to be two-dimensional, what number satisfies both simultaneously? That's what this little bracket dude means. It means system. I like to think about it as uniting these two simultaneously. So another name for this is simultaneous equations. You can think of it kind of how you want. I like that piece of vocabulary though. So to solve these, you can do all kinds of things. You're going to learn this, your methods to solve systems are all kinds of different ways. You can find your favorites. We're just going to stick with something real simple today. We're not going to look at substitution or elimination in this video or other methods for systems. We're just going to look at doing them graphically, because we've been doing quite a few graphs of lines. So I think we know how to graph these lines. So these are two separate problems, yeah? Number 1 and number 2, to clarify. So number 1, you guys help me graph that first line. Now you want to graph these really nice and neat. So your homework this time isn't going to be using graph paper. You're going to use the Khan Academy to drag the lines to where they're exactly where they need to be, so you don't have to be super nice and neat. I think that's kind of a good way to start out. So that's where we're starting today. Well, where should I start if I'm going to draw this guy? This guy. 6. 6 where?
6 y.
The y, yeah, nice, awesome. So we got that down, good. So you guys are knowing lines already. If you know them well, by the end of the year, you're going to be good to go. So I start with the y-intercept, and then I go where from there? I use this number, which is really just 1, or in other words, 1 over 1. There's not 1/2 there, there's nothing, which means the coefficient is 1, so 1 over 1 is up 1 over 1. So there's my line. I don't know if I did a good enough job to solve this guy, but when you do it on Khan, it'll help you out. Then I'm just going to graph the other one. Not even worrying about the idea of a system yet. So where am I starting on that second guy? 3. So here, make him green. And the slope on this one says go down 1 and over 2. So down 1 over 2 is a little bit flatter, something like this. Oh, now we see if my graph is good enough to do this. I don't think so, I'm not trusting it. But the simultaneous answer to the system of both lines together, does it have one answer? Does it have 2 answers, 3 answers, 4 answers? It has 1 answer. Where's the answer that's the same for both of them? Where they cross, exactly. That's the solution to the system that you're looking for right here. So the only question is, did I draw good enough to see that, you know? So if I try to be careful here, let's see, that looks like maybe -2. You guys feel it? And then like 1, 2, 3, 4. So that's I proposed one solution to this system of equations. Now if that's actually the real solution, it should satisfy both equations if I plug it in. Now you don't have to do this, right? I'm just going to show you just for the theory. Sometimes they do ask you to do things like this. So take that and plug it in. So I'm going to plug it into the first one. So y is 4. Really don't need this, do I? X is -2 plus 6. 6 minus 2 is 4. Is 4 4?
Yeah.
Check. It works on that one. Good. My drawing was good enough so far. It should also work in this one if it's truly an answer to both, right? So a little bullet point there. So let's see, if I put it in here, then 4 is y. -1/2 x plus 3. So I get 4. I think negative and negative is positive. 2 over 2 is 1. My drawing was good enough. Hallelujah. That's unusual for my drawing sometimes. So. Okay. So you guys get the idea, though. We're trying to find the point, if there is one, maybe there's more than one, that satisfies both at the same time. That's all you're doing with the system. There's all kinds of ways to do it. The only way we're using is draw the graph. It's not very sophisticated today. Pretty simple. Okay? All right. So let's do one more. This guy. Now, I want us to think before we do this guy, what are the different possibilities of what could happen? If we have just two lines, let's just think all of our systems from the beginning of, and most of this year, you're going to look at just two lines and make it nice and simple. What are the different things that could happen? Well, like the last one, the lines could like cross somewhere, right? How many solutions are you going to get every time if they cross somewhere?
One.
Just one. You sure you can't get two?
Yeah. Well,
how come?
It's 3 lines. But
Unless it's 3 lines, yeah.
Yeah.
Or like maybe if you had a curvy line, then you could get it to maybe cross twice, but the only way to get it to cross more than once now is to bend or curve that line.
Do they always intersect?
Good question. So this could happen. Ms. Porter, what else could happen?
They could be parallel.
They could be parallel, like those ones we just did a second ago, right? Something like this. In that case, how many solutions are there to the system? 0. Because a solution to the oh, there's no answer. Some problems have no answer. This problem has one solution. That guy, that coordinate, x, y. So your solutions should always have an x and a y, right? Their point. This one, they don't cross anywhere, so it has no solutions. There's one other possibility. We said that we couldn't get 2 solutions because we'd have to bend a line. You could on other systems where they're not both lines, but we're just looking at straight up lines today. What's the only other possibility you could have with just 2 lines? There's one other one. A little harder to guess sometimes. So what if I had this line? And then, just by coincidence, the second line did this and laid right on top of it.
There'd be multiple answers.
Yeah, this one, that one, that one, that one. How many answers?
Any point, it would be unlimited, basically.
So this would be infinite. Yeah, you're right. This would be infinite solutions. But it's not every solution, right? It's not every point in space, because if that's the case, is this an answer? How about this?
No.
How about this?
It's only the ones on the line.
Okay, let's say it just like that. Let's say infinite solutions on the line. It's perfect. So a lot of people get a little bit confused in higher level classes because they're not specific enough about infinite solutions and no solutions. Like, that's a great way to specify this one. Okay, so it's infinite solutions on the line or lines, since they're copying onto each other. So let's see if that happens on the second example. So you guys help me graph this one?
Just from looking at the actual what they are, I can guess the solution really easily.
Good. So Kalenda's already taking the next step. She's starting to look at the actual equations and just start to try to guess. First of all, which one of these 3 things is it going to be? That's easy to guess, and that's what one of the con exercises is going to ask you to do. And also, can you maybe even just guess where they cross? That's harder, but possible for sure. And there's all kinds of ways to do it besides what we're doing today. So let's ask. So what do you think, Kalenda, then? On this system, what are we going to have? We're going to have 1 solution, 0 solutions, or infinite solutions?
1 solution.
1 solution, why?
From the -7, since they both have the same place where B starts, then I would probably -7 would be the Y, and then 0 would be X.
Yeah, I think that's right. She's guessing the answer. The key here, though, is that the slopes are different. If the slopes are different, even if they're close to the same, like this, what's going to happen down here? They're going to cross, and you'll have 1 answer. If they're vastly different, then they're clearly going to cross, like right here, and have 1 answer. If the slopes are the same, that's where you're going to get no answers. Unless the slopes are the same and the intercepts are the same, that's going to be the infinite answer one. So let's look at a couple of those. This one's going to have 1 answer, though. Glenda's right. We're going to start in -7, right? Go up 5 over 1. So up 5 over 1 is something like that. Then we're going to start at -7 in the same spot. Oh, so the starting spot's the solution.
Down 2.
Go down 2 over 1. So that's going to look like that. But the key here is that the starting spot was actually the solution. So that was a pretty easy problem. Yeah. Okay, so I don't want the exact solution on each one of these. I just want you to tell me. Does it have one solution, none, or infinite? Because those are the only 3 things that could possibly happen.
So just on the slide.
We could graph them, right? We could graph them to try to find it. One of the other things is you should just be able to look, like Kalani was saying, and say how many answers there's going to be. So the first problem, how many answers are we going to have? 1, none, or infinite? Well, one slope says go up 1 over 6. That's something like this, nice and flat.
Oh, then never mind.
The other one says go down 1 over 6. This is something like that. Do they cross?
Yes.
Yes, their slopes are different. So how many answers? At this point, it's like the answer is at my elbow, right? So the answer is 1. So here we'd say the slopes are different. So one solution, xy. I don't know what it is. I'd have to graph it or use another technique. Okay. Second problem. 1 solution, 0 solutions, or infinite?
One. No, 0.
What's the slope on this?
Oh, there would be a line.
Wouldn't they be on top of each other?
Yeah.
Yeah, because
They're on top of each other. That's why.
there's a 3x and 3x and they would be negative.
Does it matter that I wrote it backwards?
No, I'm
It's
thinking
still the same thing, right? So you're right. It's the exact same thing. I mean, this is 3x minus 8. This is 3x minus 8 in a different order. So that's the same line. So we'll say same slope, just to be clear, same slope and same intercept means they are the same line, so infinite solutions on the line, like Hunter said. Okay, last one. 0 solutions, infinite solutions, 1 solution, 6 solutions.
1 solution.
One says start at 7 and go down 1 over 3 from there. This is 7, yeah? Imagine. The other one says start at 14. Say 14's up here and go down 1 over 7.
Those are parallel.
Those are parallel. Okay. So these guys are parallel lines. So they don't cross at all. So no solution. They have the same slope. Same slope without the same intercept like this one had. It's going to be parallel. Okay? So I think that's about it. You guys want to go look at your con practices number 3 and 4 now?